Today we're talking about writing equations of parallel and perpendicular lines. Parallel lines are two lines that lie in the same plane and never intersect. Perpendicular lines are two lines that lie in the same plane and they intersect, and where they intersect, they form four right angles or four 90-degree angles. So how do we know on a coordinate plane if lines are parallel or perpendicular? Well, here's a few important rules. All vertical lines are going to be parallel. If we have lines that have undefined slopes and they're vertical, they will be parallel to one another. When it comes to the non-vertical lines, we know they're parallel if and only if they have the exact same slope. So if two lines have the exact same slope, they will be parallel. Vertical lines are perpendicular to horizontal lines. So vertical lines have an undefined slope and horizontal lines have a zero slope. Where a vertical and a horizontal line meet, they will form four 90-degree angles and are therefore perpendicular. When it comes to non-vertical lines, we know they are perpendicular if and only if their slopes are negative reciprocals of each other. So what that means is if I have a first line with a slope of 5, its negative reciprocal is negative 1/5. So another line with a slope of negative 1/5 would be perpendicular to that line. If I have a line with a slope of 2/3, its negative reciprocal is negative 3/2. So a line with a slope of 2/3 and a line with a slope of negative 3/2 will be perpendicular to each other. If I have a line with a slope of negative 4, its negative reciprocal is negative 1/4 or positive 1/4. So a line with a slope of negative 4 will be perpendicular to a line with a slope of positive 1/4. So let's take a look at these lines and determine if any of them here are parallel. In order to decide if they're parallel, I have to figure out what their slopes are. So first I'm going to look at line A. So line A is the blue one right here. And I've got 2 points marked for me. I'm going to start at that one over there all the way on the left. And this point, to get to this point, has to go down 1 and over 5 boxes. So down 1, that's my rise. And to the right 4, that's 5. So my slope is negative 1/5. For line B, they also have marked 2 points for me. I'm going to start at the point over on the left here, and I have to go down 1 and over 4 to get to the new point. So my rise is negative 1, and my run is 4. So my slope is negative 1/4. Now these two don't match, so even though I don't see them intersecting on this graph, they're not going to be parallel. Eventually, if they were extended farther, they would intersect. So let's take a look at line C. So line C, I'm going to start at this point on the left. I go down 1 and over to the right 5. So negative 1/5. So I do have a match between line A and line C. So in this graph, line A and line C are parallel. It's important to keep in mind that we're only seeing a snapshot of these lines. They do continue, that's why they have arrows on the end. So even though we don't see any intersections here, it doesn't mean that if these lines weren't continued, they wouldn't intersect. The only way to know for sure that they are parallel is to make sure they have the same slope. All right, let's look at some equations, and from the equations determine if any of these lines are parallel or perpendicular. So I like this equation because it's in slope-intercept form. So it's very easy for me to look at that equation and know that the slope of line A is 4. So here my slope is 4. On this one, it's not as easy to see what the slope is. So I'm going to do some maneuvering and change this equation into slope-intercept form. The first thing I'm going to do is get rid of the x over here. So I'm going to subtract x from both sides. I now have 4y equals negative x plus 3. Now I'm going to divide everything by 4. Now to make this a little easier to understand here, I can always slip my ghost 1 right in here in front of this x. So this is going to become negative 1/4 x plus 3/4. Both terms were divided by 4. So my slope here for this line is negative 1/4. I'm also going to do a little maneuvering on this guy because I also want to put him in slope-intercept form so I can find that slope. So the first thing I'm going to do is add 2x to both sides here. So I have negative 8y equals 2x plus 16. And now I'm going to divide everything by negative 8. So this will cancel out. On this side, 2 divided by negative 8 is going to reduce to negative 1/4 x. And 16 divided by negative 8 is going to be negative 2 or minus 2. So my slope for this line is negative 1/4. So right away, it's pretty easy to identify my parallel lines. Line B and line C are going to be parallel because they both have a slope of negative 1/4. So line B and line C are parallel. Oops. Now the negative reciprocal of this guy would be negative 4 or positive 4. So this line is actually going to be perpendicular to line A. So line B and line A are perpendicular. And also, since this guy had the same slope, his negative reciprocal would also be positive 4. So line C and line A are also going to be perpendicular. All right, the last thing we're going to do is write some equations with the information given to us. So they want us to write the equation of a line that passes through the point 5 comma negative 4 and is parallel to the line y equals 2x plus 3. Well, since the line that I'm writing an equation for is going to be parallel to this one, they're going to have the same slope. And the slope here is 2. So I know that my line that I'm writing an equation for has to have a slope of 2, and it goes through the point 5 comma negative 4. So with the information given, the most logical form to write my equation in is point slope form. So y minus my y value is negative 4 equals my slope times x minus 5, my x coordinate. I'm going to simplify this guy a little bit and try to put him into slope-intercept form. So I have y plus 4 equals, I'm going to distribute 2x minus 10. And to get y by itself, I will subtract 4 from each side. So y equals 2x minus 14. There's my equation. Here they want an equation of a line that passes through negative 3 comma 1 and is perpendicular to the line y equals 1/2 x plus 3. So since they're perpendicular, this guy that I'm writing an equation for is going to have a negative reciprocal slope to this line's slope. So this line has a slope of 1/2. That negative reciprocal is negative 2. So my line is going to have a slope of negative 2, and it goes through the point negative 3 comma 1. So once again, I'm going to write my original equation in point slope form. It's the most logical given the information that I have. And then I'm going to try simplifying it. So the first thing I'm going to do is change this minus a negative into x plus 3. Now I'm going to do some distributing. Y minus 1 equals negative 2x minus 6. And I'll add 1 to each side to get y by itself. So y equals negative 2x minus 5. And there's my equation in slope-intercept form.